We're going to look at two series. The first one is the summation n equals 1 to infinity of 5 raised to the power 1 over n minus 1. And the second series looks similar. Summation n equals 1 to infinity 5 raised to the power 1 divided by n squared minus 1. And we're going to use the limit comparison test, which I'll abbreviate by LCT. Recall, limit comparison test works like this. Suppose we have two series. One we'll call summation a sub n, and the other we'll call the summation b sub n, with a sub n and b sub n positive for all n. And then if we take the limit as n approaches infinity of a sub n over b sub n, and that limit is L, and L is positive and finite, then either the a sub n series and b sub n series both converge, or the a sub n series and the b sub n series both diverge. What we cannot have, a sub n series converging and b sub n diverging, and vice versa. So let's return to the first of our series, the summation n equals 1 to infinity of 5 raised to the 1 over n power minus 1, and we'll call this our series summation 1 to infinity of a sub n. Now we're going to select the b sub n series as follows. Let n summation from 1 to infinity b sub n be the exponent of 5, which in this case, this becomes summation n equals 1 to infinity of 1 over n. That, of course, is the harmonic series. And now let's look at the limit as n approaches infinity of a sub n over b sub n. In this case, that is the limit n goes to infinity 5 raised to the power 1 over n minus 1 divided by 1 over n. And this will be the same as if we were looking at continuous functions. So let's evaluate this as follows. Limit x approaches infinity, 5 raised to the power 1 over x minus 1 divided by 1 over x. Now let x go to infinity. 5 to the 1 over x approaches 5 to the 0, which approaches 1, and that is the numerator approaches 0. Denominator also approaches 0. We can now use the L'Hopital's rule, and that's equivalent to the limit as x approaches infinity. Derivative of the numerator is 5 to the 1 over x times the derivative of 1 over x, that's minus 1 over x squared, times ln of 5. Note derivative of 1 is 0. And in the denominator, we have the derivative of 1 over x is minus 1 over x squared, which can now, these two can be canceled. Let x go to infinity. 5 to the 1 over x approaches 1. And so our limit is ln of 5, which is finite and positive. And that means that the two series, according to the limit comparison test, the two series, the summation n equals 1 to infinity, 5 to the 1 over n minus 1, and the summation n equals 1 to infinity, 1 over n, either both converge or both diverge. Now this series is familiar to us. This is a harmonic series, and this series diverges. And now we can conclude that the series summation 1 to infinity 5 to the 1 over n minus 1 also diverges by limit comparison test. Let's look at series number 2. And now that we saw series number 1, this should be fairly easily solved. This is the summation from 1 to infinity, 5 raised to the power 1 over n squared minus 1. We'll call this our a sub n series. And just like before, the summation from 1 to infinity of b sub n will be this series made up of the exponents of 5. So the summation from 1 to infinity, 1 over n squared. Let's evaluate the limit as n goes to infinity of a sub n over b sub n. And this is equal to the limit as n goes to infinity, 5 raised to the 1 over n squared power minus 1 divided by 1 over n squared. That's the limit as x approaches infinity. 5 raised to the 1 over x squared minus 1 divided by 1 over x squared. Let x go to infinity. The numerator approaches 0. The denominator approaches 0. We can apply the L'Hopital's rule. Carefully take the derivative of the numerator. This is the limit x goes to infinity. 5 to the 1 over x squared. The derivative of 1 over x squared is minus 2 over x cubed times the natural log of 5 divided by minus 2 over x cubed. Once again, these cancel. When x goes to infinity, 5 to the 1 over x squared goes to 1, and we end up with a positive finite limit of natural log of 5. And let's put these two series next to each other. Summation n equals 1 to infinity, 5 raised to the 1 over n squared minus 1 series, and the summation n equals 1 to infinity, 1 over n squared series. This we know is the p series with p equals to 2. It converges, and we can conclude now this series also converges by using limit comparison test. For more videos, visit www.mathprepvideos.com.